October 3, 1942. The mechanical engineering laboratory of the Imperial Japanese Navy in Yokosuka hummed with activity as senior metallurgist Hiroshi Tanaka peered through an industrial microscope at a fragment of steel. Outside, autumn rain fell against the windows, while inside, under the harsh laboratory lights, Tanaka believed he was examining nothing more than another sample of inferior American manufacturing, evidence of the technical superiority that would eventually secure victory for the Empire of Japan. What he would discover in the coming months would shatter not only his professional assumptions, but the foundational beliefs that had propelled Japan into conflict with the Western powers. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the untold story of how a small team of Japanese scientists came face to face with the industrial reality of America's war machine, and how their discoveries revealed the unbridgeable gap between Japanese ambitions and American production capabilities, a revelation that would transform their understanding of the conflict they were engaged in. The steel fragment that sat beneath Tanaka's microscope had been cut from the side armor of an American M4 Sherman tank, recovered from the jungles of Guadalcanal. The sample had arrived along with dozens of others, pieces of aircraft aluminum, artillery casings and ammunition components, all part of the Imperial Japanese Navy's systematic effort to understand and counter American military technology. Lieutenant Commander Masao Watanabe, head of the Naval Technical Department's Materials Division, had personally requested the analysis, marking it as top priority. "Any findings yet, Tanaka-san?" Watanabe asked, his tall figure casting a shadow across the laboratory workbench. Despite his military bearing, Watanabe had been trained as an engineer at Tokyo Imperial University before the war. "Initial observations suggest nothing special," Tanaka replied without looking up from the microscope. "The Americans appear to be using standard medium-carbon steel with some nickel content, nothing we cannot match or exceed." His voice carried the confidence of a man who had spent 20 years studying metallurgy, including 3 years at the Massachusetts Institute of Technology in America, before relations between the countries had deteriorated. "That cannot be correct," said Watanabe, his voice tense with frustration. "Reports from the front indicate that our Type 97 anti-tank shells often fail to penetrate these Sherman tanks, even at optimal firing ranges. There must be something we are missing." Tanaka finally looked up, pushing his wire-rimmed glasses higher on his nose. At 46, his hair was already streaked with gray, the result of years bent over microscopes and furnaces. "Science does not lie, Commander. Perhaps the issue lies with our ammunition or the gunners themselves." The exchange was witnessed by Akira Yoshida, Tanaka's 29-year-old assistant who had been recording measurements in a leather-bound notebook. Yoshida had joined the laboratory just before the war, having graduated with honors from the Imperial University. Unlike his mentor, he had never visited America, his knowledge of their industrial capabilities limited to what he had read in technical journals that had ceased arriving after Pearl Harbor. "Sir," Yoshida ventured cautiously, "might we conduct a more comprehensive analysis? The Americans have access to resources we do not. Perhaps there are elements or techniques we have overlooked." Tanaka considered his assistant with a mixture of professional respect and paternal condescension. "Very well, Yoshida-kun. Prepare samples for chemical analysis, microscopic examination, and hardness testing. Let us be thorough, if only to confirm what I already suspect." As the 3 men discussed the analytical approach, they were unaware that the simple steel fragment before them would become the catalyst for a profound reassessment of Japan's industrial capacity and ultimately its ability to sustain the war effort against the United States. Lieutenant Commander Watanabe nodded, satisfied that the matter would receive proper attention. "I will return in 3 days for your preliminary findings. The Army Technical Bureau is also examining captured American equipment. We will compare notes." With that, he departed, leaving Tanaka and Yoshida to their work. The systematic analysis began immediately. Working through the night, Yoshida prepared multiple samples from the Sherman tank armor fragment. Each piece was carefully labeled, photographed, and subjected to a battery of tests. The steel was etched with acid to reveal its microstructure. heated to various temperatures to test its thermal properties, and subjected to impact tests to measure its resilience. By morning, preliminary results began to emerge. Yoshida, having worked through the night, approached his mentor with evident confusion. "Professor Tanaka, I believe we have inconsistent results," he said, placing a sheet of figures before the senior scientist. "The chemical composition appears standard: 0.5% carbon, 1.5% nickel, trace amounts of manganese and silicon. But the hardness and impact resistance values are significantly higher than our reference standards for such composition." Tanaka frowned, taking the report and studying it carefully. "Equipment error. Perhaps. Recalibrate and repeat the tests." For the next 2 days, the laboratory became the center of increasingly intensive investigation. Additional equipment was brought in from other departments. Senior technicians were consulted. The samples were sent to the Imperial University for verification by independent analysis. When Lieutenant Commander Watanabe returned on the 3rd day, he found not the clear answers he had expected, but a laboratory in disarray filled with puzzled scientists. "What is the meaning of this?" he demanded, surveying the scene with growing concern. Tanaka looked up from a conference with 3 other scientists, his normally composed face showing signs of professional agitation. "Commander, we have encountered unexpected findings. The American armor demonstrates properties that do not align with its apparent composition." "Explain," Watanabe said curtly. "The steel appears ordinary in composition," Tanaka began, "but its performance characteristics exceed what should be possible with those materials. It is as though they have discovered some method of treatment that enhances the metal's properties beyond conventional metallurgical understanding." Yoshida stepped forward, holding a polished cross-section of the armor plate. "Commander, observe the grain structure under magnification. It shows evidence of controlled cooling processes, far more precise than our current industrial capabilities allow on a mass production scale." Watanabe's expression darkened. "Are you suggesting the Americans have superior metallurgical techniques?" "Not necessarily superior knowledge," Tanaka qualified carefully, aware of the political implications of his words, "but perhaps superior industrial application. Their ability to maintain such precise quality control in mass-produced armor suggests manufacturing capabilities that—" He hesitated before continuing, "that may exceed our own." The laboratory fell silent. Such an admission carried weight beyond mere technical assessment. "I want conclusive evidence before any such claim is made officially," Watanabe said finally. "Continue your investigation. I want comparative analysis with our Type 3 Chinu tank armor, and I want material samples from different American tanks to confirm this is not an anomaly." The investigation expanded. Through military intelligence channels, Watanabe secured additional samples from American Sherman tanks captured in different theaters of operation: the Philippines, New Guinea, even pieces recovered from North Africa via their German allies. Meanwhile, Yoshida made a discovery that would prove crucial to understanding the American advantage. While examining production marks stamped into the back of one armor plate, he noticed something unexpected. "Professor, look at these markings," he said, calling Tanaka to his workbench. "They appear to be batch numbers and dates, but also," he pointed to a small stamped symbol, "this appears to be a manufacturer's mark, and it does not match any of the known major steel producers we have intelligence on." Tanaka examined the mark carefully. "Carnegie? No. United States Steel? No, this is unfamiliar. Make a sketch and forward it to intelligence. Perhaps they can identify it." 2 weeks later, the answer arrived in a confidential report. The symbol belonged to a company called American Rolling Mill Company in Middletown, Ohio, a manufacturer previously not considered significant in Japanese intelligence assessments of American war production. "That cannot be right," Tanaka said when the report was presented. "Our pre-war intelligence indicated only 8 major steel producers with military production capability in the United States. This American Rolling Mill Company was not among them." Lieutenant Commander Watanabe, who had begun visiting the laboratory daily as the investigation gained importance, offered an unsettling insight. New intelligence suggests our pre-war assessments were incomplete. American industrial mobilization has brought dozens of previously commercial manufacturers into military production. The implications were beginning to crystallize, but the full technical mystery of the armor's performance remained unsolved until early December 1942, when a captured American technical manual arrived via submarine from Germany. The manual, partially damaged by water but still legible, contained information on American steel production techniques for military applications. Yoshida spent days translating the technical German translation of the English original. When he finally presented his findings to Tanaka and Watanabe, his voice was steady but his expression grave. "The Americans are using a process called face hardening," he explained, pointing to diagrams he had recreated from the manual. "They heat the outer surface of the armor to specific temperatures while keeping the core at a different temperature, then use controlled cooling with enormous water-quenching facilities. This creates a gradient of hardness, extremely hard on the outside to deflect incoming projectiles, but more flexible in the core to prevent brittleness and cracking." "That is not revolutionary," Tanaka objected. "We understand such techniques. The Germans have used similar methods for their Tiger tanks." "Yes, Professor," Yoshida acknowledged, "but the scale and precision are what matter. According to these specifications, the Americans have automated the process using temperature control systems that allow them to produce consistent results across thousands of vehicles. And they are doing this not at one or two specialized facilities, but at multiple plants simultaneously." Lieutenant Commander Watanabe, who had been silent, finally spoke. "How many plants would be required to produce armor plate at the rate the Americans are deploying these tanks?" Yoshida hesitated before answering. "Based on our estimated production capacity per facility and the number of Sherman tanks encountered across all theaters, at least 15 to 20 major facilities operating at full capacity." The number hung in the air. Japan possessed only 3 facilities capable of producing armor plate of similar quality, and none could match the volume or consistency described. The investigation continued into 1943, expanding to include other American equipment. Samples of aircraft aluminum from downed B-17 bombers revealed similar evidence of mass production techniques that maintained high quality across thousands of units. Artillery shell casings showed standardization that allowed for interchangeability across different manufacturing sources. By April 1943, Lieutenant Commander Watanabe was summoned to Imperial Japanese Navy headquarters in Tokyo to present the findings of what had become known as the Materials Capability Assessment Project. Tanaka and Yoshida accompanied him to provide technical expertise for the presentation. The meeting took place in a wood-paneled conference room within the Ministry of the Navy. Present were Vice Admiral Takeo Kurita, Director of Naval Intelligence Rear Admiral Shigeru Fukudome, and several staff officers responsible for production planning and logistics. Watanabe stood at attention before the assembled officers, his voice measured as he delivered the report's conclusions. "Honorable leaders, our technical assessment of American military equipment, particularly tank armor, aircraft components and ammunition, has revealed significant disparities between our pre-war intelligence on American industrial capabilities and the current reality." He continued, outlining the specific findings regarding the Sherman tank armor and its production techniques. As he spoke, the faces of the senior officers remained impassive, though several exchanged glances as particularly concerning points were raised. "In summary," Watanabe concluded, "our investigation indicates that American industrial output not only exceeds our own in quantity, which we were aware of, but also maintains quality standards across mass production that our current manufacturing base cannot match without significant reorganization and investment." A heavy silence followed his presentation. Finally, Admiral Kurita spoke. "Commander Watanabe, are you suggesting that our technical personnel are inferior to the Americans?" "No, Admiral," Watanabe replied carefully. "Our engineers and scientists are individually equal or superior to their American counterparts. The issue lies in industrial application. The American system of mass production allows them to implement technical innovations across their entire manufacturing base with a speed and consistency we cannot currently match. Professor Tanaka, who had been invited to provide his expert assessment, added his perspective. "Admiral, if I may, this is not a matter of theoretical knowledge, but of industrial scale and standardization. The Americans have created a system where scientific improvements are rapidly transmitted to the factory floor and implemented with remarkable consistency." Rear Admiral Fukudome, who had been studying the written report in silence, looked up. "Your analysis states that a single American plant, this American rolling mill company, produces more armor plate per month than our entire naval production capacity combined. Is this assessment accurate?" "Based on our analysis of production marks and intelligence reports of tank deployments, yes," Yoshida confirmed, having been granted permission to address the senior officers directly due to his technical expertise. "And it appears to be just one of at least a dozen such facilities." The meeting continued for 3 hours, with detailed questioning about specific technical aspects and potential countermeasures. The implications, however, were clear to everyone present. Japan was facing not just an enemy with superior resources, but one whose industrial organization multiplied those advantages many times over. As the meeting concluded, Admiral Kurita issued new directives. The findings would be classified at the highest level, shared only with specific technical and planning personnel. A joint Army-Navy task force would be established to explore potential improvements to Japan's production systems. And most urgently, weapons designers would be tasked with finding ways to neutralize American armor advantages through more sophisticated ammunition designs rather than trying to match their production capabilities. On their return journey to Yokosuka, Tanaka, Watanabe, and Yoshida sat in silence in their compartment on the naval staff train. Finally, Yoshida spoke. "Will it make any difference, Professor? Our findings, I mean." Tanaka considered the question carefully before responding. "Technically, yes. Our weapons designers will adapt. We will find ways to concentrate our limited resources on specific technical solutions, but industrially." He left the thought unfinished. Lieutenant Commander Watanabe looked out at the passing Japanese countryside. The small farms, the scattered factories, the lack of the vast industrial complexes he had once seen in America as a naval attaché before the war. "We miscalculated," he said quietly, "not our capabilities or theirs in isolation, but the relationship between them. We saw their resources, but underestimated how effectively they would organize them." The 3 men returned to their laboratory, where the work continued. Over the following months, they expanded their investigation to include every piece of American equipment they could obtain. Each new sample reinforced their initial findings. American industry was producing war material that combined high quality with enormous quantity. In July 1943, their work took an unexpected turn. A damaged American M10 tank destroyer was recovered relatively intact following an encounter in the Solomon Islands. Unlike the Sherman tanks they had previously examined, this vehicle featured a new type of armor arrangement. "This is different," Yoshida noted as they examined the first samples in the laboratory. "The armor plate is sloped at a more extreme angle than our designs or previous American models." Tanaka nodded as he studied the samples. "The physical principle is elementary. Sloped armor effectively increases the amount of material a projectile must penetrate. But the engineering implementation is sophisticated." Further analysis revealed that the Americans were compensating for having slightly thinner armor by optimizing its angle of presentation, effectively increasing protection while reducing weight and conserving strategic materials. "They are iterating their designs," Lieutenant Commander Watanabe observed, "learning from combat experience and rapidly implementing improvements across their production lines." By contrast, Japanese tank designs were relatively static, with major changes requiring extensive retooling of limited production facilities. The ability to continuously improve designs while maintaining high production volumes represented yet another American advantage. As 1943 progressed, the scope of the investigation broadened to include not just materials, but manufacturing techniques. Through intelligence reports and examination of captured equipment, Tanaka's team discovered evidence of production innovations that shocked them. Interchangeable parts manufactured at different factories, thousands of kilometers apart, that could be assembled without manual fitting. Automated welding techniques that created stronger joints with less skilled labor, and standardized components that simplified both production and field repairs. In September 1943, Yoshida made another significant discovery while examining engine components from a crashed American aircraft. "Professor, look at these engine blocks," he said, pointing to microscopic patterns in the aluminum. "They appear to have been die-cast rather than individually machined." Tanaka examined the components with growing concern. Mass production techniques adapted for precision components. They are treating aircraft engines like automobile parts. The implications were profound. Japan's aircraft industry relied heavily on skilled craftsmen performing precision machining for critical components. American manufacturers had developed techniques to achieve similar results through automated processes that required less skilled labor and produced more consistent results. By the end of 1943, Tanaka's laboratory had compiled an extensive technical assessment of American manufacturing capabilities. Their report, now expanded to over 300 pages with detailed technical appendices, painted a sobering picture. American industry was not just outproducing Japanese factories, but was doing so with increasingly superior design, materials, and quality control. Lieutenant Commander Watanabe arranged a final briefing for senior naval staff in December 1943. The meeting took place not in the grand conference rooms of the Naval Ministry, but in a smaller, secure facility underground, a tacit acknowledgement of the increasingly difficult military situation as American forces advanced across the Pacific. Present at this meeting were representatives from the Army Technical Bureau, Naval Planning Staff, and industrial advisors from major Japanese corporations, including Mitsubishi and Kawasaki. The purpose was not simply to share findings, but to explore potential responses to the industrial disparity that had been documented. Watanabe began the presentation with characteristic directness. "Gentlemen, our technical analysis confirms what our strategic situation increasingly demonstrates. We are facing an industrial opponent whose production capabilities exceed our own by factors of 5 to 10 in most categories of war material, and whose technical implementation often exceeds our own despite our theoretical knowledge." He proceeded to outline specific examples. American shipyards launching a new destroyer escort every 2 weeks compared to Japan's 6 to 8 months. Aircraft factories producing hundreds of fighters monthly compared to Japan's dozens, and tank production that outpaced Japanese output by a factor of 15. Professor Tanaka then took over the presentation, focusing on the qualitative aspects. The consistency of American manufacturing allows them to make continuous incremental improvements without disrupting production. Their industrial organization permits technical innovations to be rapidly disseminated across multiple production facilities simultaneously. The meeting took on a somber tone as the implications were discussed. An Army colonel from the Technical Bureau pointed out that Japan's industrial base was already operating at maximum capacity with severe resource constraints. A naval planning officer noted that shipping losses to American submarines were further restricting the flow of raw materials needed for military production. "What do you recommend?" asked the most senior officer present, Rear Admiral Toshikazu Omai from the Naval General Staff. Watanabe exchanged glances with Tanaka before responding. "From a purely technical perspective, Admiral, we must focus our limited resources on asymmetric capabilities. We cannot match American production of conventional weapons, so we must develop systems that nullify their advantages." The recommendation led to increased support for programs already underway. Specialized anti-tank weapons, suicide attack systems such as the kamikaze aircraft and Kaiten human torpedoes, and other desperate measures that reflected Japan's deteriorating strategic position. As the meeting concluded, Rear Admiral Omai addressed a question directly to Yoshida, who had remained silent throughout most of the discussion. "Young man, you have spent more than a year studying American equipment. In your assessment, when did they develop this industrial capability? Was it something they created after the war began?" Yoshida considered the question carefully. "No, Admiral. based on production marks, manufacturing techniques, and the evolution of their designs. These capabilities were largely in place before the war. What we are seeing is the application of pre-existing industrial systems to military production, not newly developed techniques. The answer hung heavy in the air. The implication was clear. Japan had initiated a conflict with an industrial power whose capabilities it had fundamentally misunderstood. In the months that followed, Tanaka, Yoshida and their team continued their technical analysis even as the strategic situation deteriorated. By mid-1944, American bombing of the Japanese mainland had begun, further restricting industrial output. In May 1944, Lieutenant Commander Watanabe was reassigned to a combat unit in the Philippines. Before departing, he visited the laboratory one final time, finding Tanaka and Yoshida still meticulously examining a new sample, this time from an American Pershing tank that had been captured in Europe and forwarded to Japan by their German allies. "Still at work, I see," Watanabe observed with a sad smile. "The technical challenge remains interesting, even if the strategic outcome seems increasingly determined," Tanaka replied. Watanabe nodded. "Our nation's leadership made decisions based on incomplete understanding of the industrial balance of power. Your work, while it came too late to alter our strategic approach, has at least helped us understand the nature of the challenge we face." He turned to Yoshida. "You were the first to recognize the significance of what we found. Remember the lessons of this experience." After Watanabe's departure, the laboratory's focus shifted. With Japan's industrial capacity increasingly under direct attack, theoretical analysis of American manufacturing advantages gave way to more immediate concerns: how to maintain minimal production capability under bombing, how to substitute increasingly scarce materials, how to simplify designs for production with less skilled labor as experienced workers were drafted into the military. In August 1944, Yoshida was reassigned to a critical project attempting to improve the performance of Japanese anti-tank weapons through better ammunition design rather than improved armor penetration. Before leaving, he had a final conversation with his mentor. "Professor, when you studied in America before the war, did you visit their factories?" he asked as they shared a simple lunch in the laboratory. "I did," Tanaka acknowledged. "I toured steel mills in Pittsburgh, aircraft plants in California, automobile factories in Detroit." "And you did not recognize the potential military significance?" Tanaka set down his chopsticks, considering the question. "I saw their scale but underestimated their adaptability. I viewed their mass production techniques as appropriate for civilian consumer goods, but not sophisticated military equipment. I failed to imagine how quickly they could convert and upgrade those systems for war production while maintaining both quantity and quality." He continued after a moment's reflection. "It was a failure of imagination on my part, and on the part of many others. We evaluated their technical knowledge, which we could match, but not their industrial systems, which we could not." Yoshida nodded slowly. "A technical assessment without consideration of scale is meaningless in modern warfare." "A lesson learned at great cost," Tanaka agreed. The two men parted ways, each continuing to serve Japan's increasingly desperate war effort in their technical capacities. Yoshida's work on anti-tank ammunition would lead to marginally improved designs, but never overcome the fundamental disadvantage in both quantity and quality. Tanaka would remain at the Yokosuka laboratory until March 1945, when American bombing damaged the facility beyond repair. In the final months of the war, as American forces approached the Japanese home islands, both men found themselves reassigned to emergency defense preparations. Their specialized knowledge of materials science was applied to increasingly improvised weapons, shaped charges made from ceramic instead of metal, concrete fortifications designed to compensate for steel shortages, and other makeshift solutions that reflected Japan's industrial collapse. On August 15, 1945, Emperor Hirohito announced Japan's surrender. In the shocked silence that followed throughout the country, Tanaka and Yoshida, reunited at a temporary research facility in the mountains northwest of Tokyo, contemplated the technical journey that had begun with that first piece of Sherman tank armor nearly 3 years earlier. "We learned too late," Yoshida said quietly, as they listened to the Emperor's broadcast on a crackling radio. Not just about their industrial capacity, but about the nature of modern warfare itself. Tanaka nodded, his face showing the strain of years of overwork and increasing desperation. The lesson was there from the beginning, in that first sample. Their armor was not technically revolutionary. It was conventionally excellent, produced at a scale we could not match. Quality in mass production defeated specialized craftsmanship. In the years following the war, both men would contribute to Japan's industrial rebirth, applying the lessons they had learned through their wartime analysis. Yoshida eventually became a leading figure in Japan's automotive industry, helping to pioneer the quality control and lean manufacturing techniques that would eventually allow Japanese industry to compete with and sometimes surpass American producers. Tanaka, already in his 50s when the war ended, served as an advisor to the Ministry of International Trade and Industry during the critical early phases of Japan's industrial reconstruction, helping to shape policies that emphasized quality control in mass production, directly applying the lessons learned from those wartime armor plates. The technical report they had produced during the war, classified and nearly forgotten in the immediate aftermath of surrender, would be rediscovered during the 1960s by Japanese industrial historians seeking to understand the foundations of the country's post-war economic transformation. Its clinical analysis of American manufacturing advantages became a blueprint for the quality-focused mass production systems that would power Japan's economic miracle in the decades to come. The steel fragment from the Sherman tank that had started their investigation was preserved by Tanaka until his death in 1972. It was then donated to a small industrial museum in Yokohama, where it remains today, a small piece of metal that revealed a large truth about industrial warfare. That victory in modern conflict depends not just on the quality of individual weapons or the courage of those who wield them, but on the industrial systems that produce them in sufficient quantity and consistent quality to overwhelm an opponent. The tactical lessons of the armor's effectiveness were significant, but the strategic lessons of its production were transformative, not just for warfare, but for the peaceful industrial competition that followed. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.